Okay, so for question 16a, it is about silicon carbide, which is an extremely hard solid with high melting point. Well, of course, although not required in this question, but high melting point, of course, if you think of SPE, well, the structure is giant covalent structure. Bonds will be strong covalent bonds between Si and carbon atoms. So of course the strong covalent bonds require a large amount of energy to break, so of course you have high melting point. Just a quick recap. So it is chemically very stable because it requires a large amount of energy to overcome the strong covalent bonds. Okay, and in this case they ask you to sketch a small portion of the silicon carbide structure. So this one is just like your diamond structure, okay, but you need to draw 3 sets. So 1 set, 2 set, and 3 sets, okay? And your silicon should be the central atom, not your carbon. Okay, so this should be your answer. And remember to write the legend. Okay, the legend to indicate which is your silicon and which is your carbon. Moving on from here, 16b, they are talking about crystal lattice. Okay, and for crystal lattice, for sodium and potassium chlorides, that means our NaCl and our KCl, the coordination number of each ion is 6. And in the crystal lattice of cesium chloride, CsCl, the coordination number has a different value. That means, of course, it is not 6. So this diagram gives us an overview of the crystal lattice of sodium chloride, and they ask you to suggest what is meant by the term coordination number when used to refer to a crystal lattice. Well, I guess from this diagram you should be able to deduce these on your own, although it is not taught. So if you just take a look at this diagram over here, use it to deduce what your coordination number is. Okay, just randomly pick one sodium plus ion and you would notice that it is attached to 1 Cl minus, 2 Cl minus, 3 Cl minus, 4 Cl minus, 5 Cl minus, 6 Cl minus, and correspond to coordination number 6. Okay, and of course, if you try it out for Cl minus, you will notice that it is attached to 6 Na plus ions as well. So based on this observation, can you deduce what is your coordination number? Okay, so in this case, you need to be able to do such observations and deductions on your own. Okay, the thinking process is important. So moving on from here, of course it should mean that the coordination number is the total number of ions surrounding another ion of opposite charge. So this is what we went through actually in this diagram. The Na plus is surrounded by 6 Cl minus, and each Cl minus is surrounded by 6 Na plus. That gives us the coordination number. Okay, I hope you have gotten this. If you have gotten it, congratulations. Okay, so for part 2, let's take a look. They ask you to suggest an explanation for the coordination number in CsCl being different from those in NaCl and KCl. So I guess in this case, again, please put on your thinking cap. Okay, so for your CsCl, NaCl and KCl, what do you think is the difference? Just pick up the difference first, because you're supposed to compare them. Well, I hope you have picked up the fact that Na plus, K plus, Cs plus, they are in this arrangement in the periodic table group 1. And what do you think will be the difference? Of course, Na plus will be the smallest, followed by K plus, followed by Cs plus. So based on this, can you deduce what is the coordination number of Cs plus, given that for Na plus and K plus the coordination number is 6? Do you think the coordination number should be more than 6 or less than 6? if your answer is more than 6, then you will be correct. Well, actually it is very logical why it should be more than 6, because it is so much bigger. More ions of the opposite charge should be able to surround it, isn't it? So based on this, let's check. Your answer should be CS plus has larger size than Na plus and K plus. Please do not put CS, Na and K in your answer because they are wrong. Take note that you are talking about ionic compounds, so you should specifically mention the positive charge. Okay, and so since it has a larger size, more Cl- could be packed around this larger CS plus ion, and hence the coordination number will be larger for CS plus ion as compared to Na plus and K plus. And in fact, this coordination number, if you go and check it out, it should be 8. Okay, it is actually more than the 6. So based on this, right, we can come up with this concept. For coordination number, it depends on the relative ionic size. So in this case, it's our CS plus is greater than Na plus and K plus. Okay, and coordination number also depends on the charges of the cations and anions. Okay, in this case, all our CS plus, Na plus and K plus have the same charge, so we do not need to talk about the factor of charge here. We just need to talk about the ionic size in this case. So I hope that you have found this question interesting.